Hi, guys. Welcome back to the podcast. Here's another episode with your host, Nick,
And Bert.
Bert. Same guy, different names, multiple
Quantum
personality
superposition.
disorder. You know what? That's a better explanation for your name. It's quantum superposition versus personality disorder. I don't know. Maybe we'll find out on the next episode on why Bert and Brett have two different names, but they're the same person.
But, Rick, what are we talking about today?
Well, we're talking about gravity. And you see,
What is
I like
gravity,
gravity.
Nick?
Well, see, gravity is that thing that keeps us on the ground. You know what I'm saying? It's like a
The floor.
floor, yeah. It is the force on the world and the podcast right there. That's all it is. No, so from what I've been reading up on, gravity is the best way to think of gravity is it's the force that is opposing everything. It opposes, I guess it would oppose thrust. It would oppose all sorts of other things. I'm trying to think of, but blanking currently. No, gravity is just the Earth keeping stuff close to it, and it's kind of a real wonky idea. I have a hard time trying to know what it is. It's my notes I had. It's a fundamental force. It it's an attractive force between objects that have mass and energy. The more massive an object is, the stronger its gravitational pull. We could think of certain examples like Jupiter, like the sun. Mostly, is Jupiter the one that has the most moons, buddy? I can't recall that.
Yeah, it's the big
Okay.
one.
It's the big one. So Jupiter, because of its massive size, it has a large gravitational pull. And most people can intuitively understand what gravity is in the sense that it's bringing you closer to the largest body around you. So, for us here on Earth, that's the Earth itself. But for Jupiter, it would pull in all of these different moons. And when the solar system was constructed all the way back in the day, Jupiter just started to get more and more moons, and the same type of attraction is the same when it comes to the sun, mostly because there are 8 or 9 planets that circulate the entirety of that sun because of gravity. And so, do you prescribe to the theory that there are 9 planets or 8 planets, Bert?
I'm an early adapter of kicking Pluto down to, lesser body.
A lesser body. So you wouldn't categorize that as a planet, would you? Like even, I mean, 10 years ago it was.
No, like in, first or second grade or something, we learned about the planets, and then it was like in the news and stuff that they were going to demote Pluto, and it was sort of the teachers and stuff tried to frame it as a debate between like 6-year-olds about like whether Pluto's a planet or not, and like most of the kids were like, you know, oh, be nice to Pluto, be good, don't kill it.
Be nice to Pluto. Pluto do to you.
I was in the anti-Pluto camp. My aunt actually got me a present. I've got it on my shelf here somewhere, like Neil deGrasse Tyson's book about why Pluto isn't a planet.
He really came out with a book that said Pluto is not a planet.
Pretty much.
All right. Okay. Uh,
It's called the Pluto Files. I'm not sure if that's a pun
uh,
on something on like Money Lovers.
maybe the X-Files.
Anyway, well, like case files, you know.
Yeah.
I mean, the biggest thing for me was that there was pretty clear precedent for thinking something as a planet and then demoting it to part of an asteroid belt. In the 1800s or whatever, they found Ceres, and they said, "Oh, well, here's a new planet. Isn't this cool and good? Here you go, new planet Ceres." Then they found a whole fucking bunch of them and said, "Well, this isn't a planet. This is just the biggest one of a whole bunch of fucking asteroids, a whole asteroid belt." And they just did the
Okay.
same thing with Pluto, but there was like an 80-year gap in between.
Huh.
Or
I'll
was
be
it
honest.
100 years? I don't know. I
I
forget.
don't think. I mean, it's so far away from the sun that it's probably closer to 100 years. Because doesn't it take like Jupiter and Neptune and all
No,
Uranus to?
I meant gap in time between like discovery and demotion.
Oh, yeah, that one I don't know. I would think 30 years then. I was
When did they
thinking
find
you were
Pluto?
talking about the
Uh,
elliptical.
1909. Yeah, so like 100 years.
Well, all right. Good for Pluto. It made it 100 years before.
Yeah, they were doing it at the Lowell Observatory, the same place where they were looking for like the canals of Mars and stuff.
Hmm, okay. So this was something I had written down. It doesn't pertain to Pluto, but it does pertain to the idea of gravity and the cosmos itself. I wrote down the gravitational attraction between matter caused the earliest structures to form in the universe after the Big Bang. Tiny fluctuations in density were amplified by the gravity across the galaxies and galactic clusters. I love that when they put that in there. Gravity drove the formation of the stars and planets as matter was pulled together by the mutual attraction. So I get the thing I was curious about that statement right there. Is it just did Pluto have some kind of non-attractive material in it, so that's why it's on the farthest reaches of our galaxy?
I zoned out for a minute. I was thinking about Pluto. What was the question?
So the question, right? Long time ago, gravity happens, blah blah blah, Big Bang. Gravity and Big Bang with all the particles everywhere start to bring everything together, because everything's attracted. And my question to you is the reason why Pluto isn't closer to the sun because of the material in Pluto? Or is it because it has something to do entirely with, hey, you just got shit out of luck because you're in this location and not this location?
Um,
Because a statement from earlier made me
I
think that.
I
Now
took
I'm pondering it.
an astronomy class in college, actually, but I'm struggling to remember what the idea was. Broad strokes, the idea was is that when you have like the solar system form, you've got like the sun at the center, and then like a huge disk of like dust and garbage and gas and stuff floating around it, and it'll accrete and coalesce into stuff, into bigger and bigger stuff, and into planets and all that. But
Yeah.
there's some kind of dance between temperature and gravity that kind of splits this disk into different zones where uh, stuff is going to form with certain characteristics. Like, I suppose gas wants to, it follows gas laws. It's less dense when it's hot, and it's denser when it's cooler. So uh, it gas giants and stuff should form in the outer solar system where it's a bit colder and it can get real dense.
That I actually didn't know.
I
So,
think that's how it works.
I mean, let's just have an
I think,
astronomer
yeah,
just.
I think the gas giant stuff should form in the outer solar system and then migrate inwards, and that uh, the there's a weird band where the in the disk where the gravity of Mars and Jupiter fuck with each other, so that there's a whole bunch of garbage that collects there, but it can't coalesce in anything big or anything much bigger than like Ceres. That's why we get the asteroid belt. How exactly like the Kuiper belt and the Oort cloud and stuff work? How do you have rocky stuff coalesce out there past Neptune and stuff? I'm not really sure. I'm not really sure anyone knows. But I don't know.
I'd be.
Like there's always going to be a few crackpots who go like, "Oh, Planet 9 or Planet 10 or whatever." Like, "Oh, there's another missing planet out there," and uh, they've always been on that. Like ever since they found like Neptune and Pluto and stuff, people have been looking for like the next planet in the sequence. But I think
I
finding
think we
out
would
the
have all of
Kuiper
the
belt
planets,
and
don't
stuff
we?
kind of fueled some of the crackpot stuff about like, oh well, if the asteroid belt is between Jupiter and Mars, and if there's another belt out there, then reasonably there has to be something on the other side. But that's, crackpot stuff, Uh, it's
Because
so
we.
cold and so dark out there. It's really hard to prove or disprove anything. I mean, they didn't find all this trans-Plutonian stuff in the Kuiper belt like until 2006. It's hard. It's not impossible. All right, like you can make a model that fits in another planet, but like that's not proof that it exists. That's proof that it could exist. It's like Russell's teapot. There could be a teapot floating out there in the asteroid belt, but like the burden of proof falls on you to bring me pictures of this fucking teapot, and how are you going to do that? you know
So it's like electron. What did fuck? What did Einstein say? It was electron theory. Like you could measure
I think that's
valence electron theory. Is that what it was?
uncertainty
That's what
principle.
it
Who
was.
is that? Is that Heisenberg? Uncertainty
I,
principle. I don't know.
mm, let me look it up because
Niels
isn't it
Bohr's
one?
or something. I don't know. Uncertainty principle. I can't spell. That would help.
We cannot know both the position and speed of a particle, such as a photon or electron, with perfect accuracy. The more we
No,
nail
no.
down the
That
particle's
that's
position, the less
that's
we know
unrelated
about it.
to
Well, if
gravity.
you don't know one, but you know the other,
That this is
okay.
unrelated.
I'm aware. I'm not saying that the principle. I'm saying I'm not saying that that principle in particular relates to what you're talking about. I'm saying that the entire context of one, show me one, even though you know the other, and then you can't do it vice versa. You know what I'm saying?
It's interesting that you bring that up. It's
Oh boy.
it's pretty unrelated to the gravity of the planets and stuff. Like the reason that it's so hard to find all these little asteroids out past Uranus and stuff is because they're very small, they're very dark, and they're very cold. It's hard to get any radar return. It's hard to get any infrared or anything in the visible light range. They're pretty negligible gravitationally. It's just hard to see them. They just slip through your fingers like dust.
Eh,
Now that you mention uncertainty, it calls to mind its weird cousin of chaos. You uh in a perfect world, you ought to be able to follow the grand chain of events and reasoning all the way back to the Big Bang. You know, you ought to be able to say, oh, well, here are Newton's laws of motion. And you should be able to say, oh, well, if this object is here, it was acted on these forces in the past, and you should be able to rewind it, like Newton's gigantic clock, handmade by God. You want to just be able to turn the hands back and watch the spring coil back up and all the gears turn in reverse, and rewind everything to the very beginning of existence.
Sure.
But it doesn't quite happen like that.
Well,
You get
before we
into chaos theory, you get into once you have like more than 3 bodies, like you can't predict anything. You get the 3 body problem where you can know the position and direction stuff of these bodies, but like it's too uncertain to predict with any degree of accuracy. Like
okay.
I'm kind of butchering it. 3 body problem is kind of weird.
The
Maybe
hell
it's
is a
not
three
exactly
body?
related.
What is a three body problem? I mean, I get the namesake. I don't understand what is it?
I'm gonna plagiarize from Wikipedia because fuck school. Uh, it's a special case of a problem uh, that results in chaos.
Okay.
Like
Such a problem that results in
if you
chaos.
had 2 planets in space, you could predict everything about them just using Newton and stuff. Once you throw 3 bodies together and start hurling them around,
Then it gets a little
uh,
fucked. Mathematically, that is. Like it just gets stupid complicated. Is that what you're saying?
it gets unpredictable. It gets chaotic. You
Okay.
become unable to predict it.
Huh. So one of the things I wanted to touch on was part of gravity is studying Albert Einstein. Like he helped to at least accelerate the field, or is that even the right word here, Bert? I think it's more of a he helped to
Well, I mean,
uh,
you have to
make it.
understand, like, the perspective of people before Einstein. You know, they were stuck in a very Newtonian universe. Uh,
Isaac Newton,
right,
but
which
but
is
he
more or
based the
less the same
principles
as like
off Isaac.
Euclid's world. It's more or less a nice geometric plane with a nice, comfy set of axioms that have been unquestioned and unchallenged. Uh, and everything should work nice and good. You know, it's sort of Newton was sort of unexplained. Newton's version of gravity was like, okay, well, why is there the force between any 2 objects? You know, why does mass cause objects to attract each other? How does it act over this distance? I don't
Fucking attraction, my guy.
know. They want to make kissy kissy to each other, so they float over.
That's exactly it. That's it. And the podcast right there. They just make kissy kissy. The the planets like the kissy kissy with all the items on top of them. That
Right. I mean, they. You go back to Euclid and stuff, and you talk about like uh parallel lines, right?
okay.
One of Euclid's axiom is like if you have 2 lines that are parallel and they extend infinitely, they'll never intersect and touch each other. Like by definition. There you go.
I mean,
And
it's
people were
unsatisfying.
used to that. What what do you mean it's unsatisfying?
Well, it's just unsatisfying. It's like this idea of
It's very
it goes.
satisfying. It's very nice and comfy. Like
How is infinity? How is that comforting? That is.
it's not that the lines are infinite, it's that it's the it's taking it as gospel that they won't touch. It was very nice for people for thousands of years to have these comfy axioms, these foundations of science and math. I mean, I don't know. I'm the type of person who looks for like the first principles and things, for like the foundation of something. And Euclid is about as foundational as it gets. you have these 5 or 6 rules, and from them everything else follows. It's Cartesian almost. It's like it's foundational. It's just gospel, and it has been for thousand years.
Until good old Isaac
Like,
Newton met
no,
Einstein and then had their baby.
Newton works on more or less those lines. I mean, people have been fucking around with spheres and stuff forever, but like the idea that, I mean, you can fuck with geometry on a globe, Have you ever seen a globe, seen all the longitude and latitude lines on there? There you go. They're all parallel lines. And yet, when
That's
you
good.
go to the poles, they intersect at right angles. Just how Euclid says that they shouldn't. But the assumption is that it's on a geometric plane. When you start bending the plane that you're working on into funny shapes, well, funny things happen.
With that. Now, I think this would be a good segue because part of us learning about gravity is this entire idea of inputting it into engineering ideas, and one of those ideas is Ringworld. How do you feel about Ringworld, Bert?
I feel pretty good about Ringworld. I mean, Ringworld doesn't rely on like relativity or anything. You don't have to like curve spacetime around yourself. You're just curving the building around yourself and spinning it.
That's true. That's true. I'm thinking more from the gravity standpoint. That's it.
Well, it's not gravity. It's momentum. It's angular momentum.
Sure.
From a physics standpoint, it's completely unrelated. It's not the force of gravity at all. It's only mimicking the effects of it.
Yeah.
Like,
But knowing about
they're
gravity
not
helps to
masses
understand
that
it.
are attracting each other.
Yeah.
It's not the warp and weft of space time. It's a circle, and you're spinning.
You're spinning.
It's
You're
an
spinning
awfully
really fast.
it's an awfully fun idea. I'm awfully fond of it. As a kid, I read Larry Niven's Ringworld, which is an awfully fun book. Larry Niven is a much better short story writer than novelist. This is true of a lot of the old crates back when they had like, regular magazine publications of short stories. Like, I feel like that ought to make a comeback. Like they killed off all these short
Wait, what?
story magazines from like the 30s and 50s and stuff. But like attention spans have shrunk so much, who wants to sit down and read a 1,000-word trilogy about all this shit? Like, why can't I just pay a subscription service to have like the best of sci-fi fantasy authors like dumped off as a few short stories every month? Anyway,
Might be an interesting. I mean, I don't fucking know. Maybe somebody's got something cooking. I don't really know. Who the hell would write these stories? And then, if they're like
like
short stories, what's the point of them?
anyone. I mean, people. I suppose maybe short story authors already exist out there where it's like, hey, subscribe to my Patreon or whatever, and I'll send you a short story every month. But like
Well,
you'd kind of prefer to have it through like a subscription service through a larger company that like hired talent and looked out for people and stuff, and like you could submit stories to them. Like, it's kind of like with Amazon and stuff. Like Sears Roebuck existed for centuries before Amazon, and like had the same model of like, here's your catalog, here's your warehouse and delivery system and stuff. Like, they went under just before Amazon showed up. Why did you get rid of these sci-fi fantasy magazines? Like, you just missed the subscription service model. You just missed the shrinking of attention spans beyond what novels permit. Like, what the fuck?
Yeah. No, this is. I would think that you would. Well, they wouldn't know beforehand, so how would they? How would they? Fucking. I guess what I'm trying to say is, how would they
Anyways,
ever try and be in that boom if you didn't know that the boom was going to happen? And I mean, even if they're a short
they just
story,
should
it's
have
like,
looked in their crystal ball and told the future, okay? I don't know what to tell you.
yeah, you're right.
Anyways, Ringworld is a fun book about, hey, wouldn't it be cool if, like, you took all the matter in the solar system and bent it into a big circle, like, somewhere around Earth's orbit, and just spun the thing for gravity and built, like, mile-high walls on the sides to keep the atmosphere in, and terraformed the inside, and just made, like, a space station habitat fucking jillions of times the size of the Earth? The answer is yes, it would be cool. You would need like exotic material to be able to handle the forces put on it. You would need. This is like godlike Kardashev scale 4 type construction project type of thing, but it's definitely not the first example of a space station using centripetal acceleration for artificial gravity. Like, people have been floating around that idea forever. I'm pretty sure the Nazis came up with like some drawings of space stations like that. I think people did probably before that in like the 1800s, drawn up space stations made out of bricks and stuff. Uh,
so how big is a ring world? I mean, is it like the size of the Earth, or is it like 3 times the
it's
size of that?
it's the size of the orbit of the Earth.
Oh fuck!
That's big. Here, I think it's sitting on my shelf over here. Let's grab it. I'll just read the fucking thing off the back of it.
Yeah.
I myself, Larry Niven, have dreamed up an intermediate step between Dyson spheres. Do we know what Dyson spheres are? Do we have to talk about that?
I think that might be a good segue because I have no idea what a Dyson sphere is, my guy.
So, you know, solar panels?
Yeah, solar panels. Those are cool.
Yeah. Have you heard about the idea of like putting solar panels in space?
Yeah.
Like, that would be cool and nice. You don't have to have the atmosphere refract it, and you can have it like be day 100% of the time instead of 50% of the time.
Okay.
Okay, now imagine you add more solar panels to space. Imagine you just cover space with solar panels. Imagine like you build a shell of solar panels around the sun. You just grab every bit of solar energy shooting out of there.
Okay. So what the
That's
hell do you
Dyson
do with all
sphere.
that? What's the point of all that energy?
You could power computers that could like simulate jillions of possible universes.
What would that be? Like a quantum computer?
Quantum computers are weird. Who the fuck knows?
Okay, getting back to Ring World.
You could make jillions of lasers for uh, laser sailing starships. Anyways, so now that we've imagined a planet, and now that we've imagined a Dyson sphere, imagine an intermediate step between them. Take your Dyson sphere and like only grab like the midsection of it. You know, a little tiny thin strip of it instead of the whole shell. Stick it there in the nice, cozy Goldilocks orbit where Earth is, and there you go. Quoth Larry Niven on the back of the book. Build a ring 93 million miles in radius, one Earth orbit, which would make it 600 million miles long. If we have the mass of Jupiter to work with, and we make it 1,000,000 miles wide, we get a thickness of about 1,000 meters. The ring world would thus be much sturdier than a Dyson sphere. There are other advantages. We can spin it for gravity. A rotation on its axis of 777 miles per hour. I'm sorry, 770 miles per second would give the ring world one gravity outward. You wouldn't even have to have a roof over it. Put walls 1,000 miles high at each rim. Aim it at the sun, and very little air will leak over the edges. The thing is roomy enough. 3 million times the area of the Earth. It will be some time before anyone complains of the crowding. So there you go. 3 million times the surface area of the Earth. This is the extreme example of a ring world. You know, like the Halo ring from like Halo. That's like a fraction of the size of this. That thing isn't around its parent star. It's like orbiting a planet. You know, it's like moon-sized. Same idea, but it's scaled way the fuck down.
I dig it.
God, Halo's also really good.
I like that. So it's not really gravity; it's artificial gravity, or it's more
It
of
has
a.
nothing. Okay. It has absolutely fucking nothing to do with gravity. Like, gravity, as we've defined it, through Mr. Newton and stuff. If you have two things with mass a certain distance apart, they'll attract each other. That's gravity. The Earth is really big and really close to you, so it pulls on you pretty hard. But you pull back on the Earth. But you're much smaller, so it doesn't come up as much. With this angular momentum, with this centripetal acceleration. What's a good example, Nick?
In what regard? We've said a lot of things in the last 30 minutes.
Oh, okay. You know when you're in the car and you take a sharp turn and your body swings to one side? Like it
I didn't know
feels like
anything
it's
about
thrown
ringworlds.
outward.
Okay.
That's what it is.
Centrifugal force?
The car is turning to one side, but your body wants to keep going the way it was going. And it feels like it's being thrown against the wall, but it's just your frame of reference changing. So when you're in space and you stand on the inside of a big ring and you spin the ring, your body wants to keep going.
So, Bert, momentum. What were you saying about it?
Right. So the idea is with the ring world, or with like a toroidal space station or whatever you call it, the idea is in space, once you start something moving, it wants to keep going in a straight line forever. You know, there's no other forces acting on it, and it'll, per Newton, do that forever. Now, if the floor rises up to meet you on the bottom of this ring, if it's pushing your feet up and pulling you in a circle, well, then the floor is going to accelerate you in a different direction. It's going to spin you around. Your body's always going to want to fling off tangential to the ring, but the floor will push it up.
Yeah.
Like, you know how a sling works? Like,
Yeah,
in
you
the
kind of
Bible
spin
and
it
stuff, like you whirl it over your head and then you let it go and the stone flies out. It's like
Yeah.
that. Like the rock is being pushed into the back of the sling, and when you let it go, it flies off 90 degrees to the circle it was making.
Well, so
Yeah, there's the ring is nice. You know, you just loop it back on itself. You walk from one end to the other. Like, that's the popular way to do it. But there's no reason that you can't just have a sling. You know, there's no reason you can't just have like 2 tin cans on a tether, whirling around each other. Like, you couldn't walk from one to the other without like traveling along the string. It would be harder to balance and stuff. But you could do that too. Does that make sense about the
yeah,
uh,
I'm finding out
center
that they're
acceleration? I in high school, I did a project and physics class for this. This is like capstone high school physics project. Like, oh, end of year, end of physics. Make a big impressive project, right? Like, some people did really stupid stuff. I think somebody did something with circuits. Someone did a really complicated series of like buckets sitting on a table with pulleys like holding themselves up. I did a really stupid project on like ringworld type stuff. I just in like 5 minutes scribbled down like how big and how fast a circle needed to beat and how fast I had to spin to uh simulate 9.8 meters per second acceleration due to gravity. I mean, it is acceleration. It is a 9.8, but it's not gravity. It's just an acceleration. And I just scribbled this down on a piece of paper, like grabbed a few pictures from the internet, slapped it on there, and brought in like this section of plastic piping, like of rain gutter stuff. Like, it was slightly bent and everything. And like I just brought this fucking foot-long piece of hose in and turned it in for a fucking final project.
hey, as long as you pass, that's all that matters. I
I'm
mean,
sorry, what were you asking?
I was gonna ask you if it was actually feasible to make a ring world. You know,
Well, it
'cause,
depends on the
now,
size and stuff. Like, if you do the math for like Larry Niven's one the size of like the whole Earth orbit, like, no, there's no material in the universe strong enough to withstand the forces needed. Uh, but to make a smaller one, like in 2001: Space Odyssey or something like that, to make like there's all types of names for this shit, like an O'Neill cylinder, Stanford Taurus, or something like that. To make a more reasonably sized one, yeah, there's no reason you couldn't make it out of like glass and steel. Same stuff as always.
okay. Because I'm trying to think of what you're putting this in space. You're literally putting it in the size of the orbit of a planet. So you're looking at least like like I don't even know if there is a conceptual measurement to make this ring world. Is there? Like, what's the measurement? Like, I need like quadrillion fuck tons of iron.
I riddled it off a minute ago. It's the mass of Jupiter.
Jesus
Like,
Christ.
I mean, that's all like hydrogen and stuff. You know, you would need like massive. You would need like a Jupiter's worth of this exotic material strong enough to withstand on forces.
All right, damn.
While I'm here talking about ringworld and gravity and stuff and exotic material, there is theoretically like really dense material out there, like stuff found in neutron stars and stuff, like entire planets where the mass like smushed down to the head of a pin.
Really?
Yeah, that would be something really small with really high gravity. You know, you could make something like King Kai's planet if you had something like that at the
We're
center
gonna
of it.
pull a Dragon Ball Z. I love it.
Yeah, why the hell not?
We're
Terry
going train.
Pratchett, before he wrote Discworld, he wrote a parody of Ringworld, which was a really clever parody. What was it called? It was called like strata or something, like archaeological strata. And that was kind of what they did. Instead of like spinning the thing for gravity, they just made a huge disk out of neutronium and said, well, it's dense enough to have like Earth gravity, but it's just in a different shape. There you go. Here's your flat planet with Earth gravity. You know, dance around on it, do whatever you want. Yeah, I mean, if you're gonna make a megastructure habitat and get exotic material, you might as well just have it be dense enough for gravity. You know, why bother spinning it if you're going to conjure up like made up materials?
Because it's fun.
Yeah.
Well,
And then he recycled the idea a bit in like Discworld and stuff, which is also really good.
so I would say for our closing statements, because this is obviously a courtroom and I had to make it sound like a courtroom, the 10 out of 10, what do you recommend here, Bert, for reading this Ringworld book? Because I might have to read it now.
Oh, like I said, you know, it's science fiction. Like the characters are like cardboard cutouts. You know, it's basically a tour of like the big fancy ring and stuff. It's sort of like Dante's Inferno. You know, like Dante isn't a super interesting character in there. Yeah, it's all right. It's a big famous work of science fiction. Like his short stories are probably more fun, more better. Uh, but if you like world building or literal world building or classic sci-fi, yeah, it's worth taking a look at.
I think that's pretty much all we got on gravity and how that doesn't fucking at all go with Ringworlds now that I found that out. That's interesting. Who would have thunk it?
Yeah, I
Actually,
mean it's like how you cheat it.
how I cheat it?
Yeah,
Or
like how you bring your own gravity in deep space and stuff.
yeah. Well, regardless, I think that pretty
I
much
don't know
wraps
if
up
there
this
are any
episode.
weird. I should look into it more. I'm not sure if I understand it. I've heard somewhere that there might be like weird problems about living on the inside of a spinning ring. About like when you spin around, like if you're standing and you turn around, there might be like weird torques or something on. I don't know. I'm not sure if that's true. I don't remember finding anything about it in high school physics, but yeah, we didn't talk too much about like Einstein, like relativity and stuff. I bitched about Euclid and Newton and how he basically flipped them on their head. About how everyone was real nice and happy with their static, flat frame of reference for space-time. And that to go stretching it around was weird. And then you get into like twin paradoxes and like universal speed limit and stuff. It's weird and like how connected is it to gravity and stuff, blah 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 blah. We didn't talk about like black holes or dark stars or whatever. I always like dark stars when they some dude in the
Dark
1800s or whatever
Star.
talked about like, oh, well, could you have a star big enough that like it attracts its own light? I think maybe it wasn't the 1800s, maybe it was after Einstein. I don't know, but I always found that more conceptually easy to talk about than like the singularity, you know. We didn't talk about Star Trek and warp drive and stuff. like conceptually it works, yeah. You sit still and just move space around you, but like, could it ever actually be built? Probably not.
Well, I
Uh,
mean, Bert, remember, are you the same animal but a different beast?
yes.
Yes. All right. Well, on that note, buddy, I think we'll end it right there. I think we'll have to come out with another episode on warp drives and dark stars
Einstein.
and yeah, maybe specifically on Einstein. That'd be kind of cool.
You know, actually talking about gravity.
I was curious on how gravity related to the ring world. I like the idea. So, regardless, my name is Nick.
My name's Bert.
Bert.
My name is Jeff. No.